guys, welcome back. So what we're looking at today is lesson 7, all, some, or no solutions. So let's go ahead and jump right in. All right, so thinking about solutions. So here are a bunch of different equations that we have. We want to sort these equations into two types, true for all values and true for no values. So if we look, we have n equals n. Well, no matter what we plug in for n, it's going to equal itself. So it's going to be true for everything. So all. The next one, we have 2t plus 6 equals 2 times t plus 3. So if we distribute the 2 to the t and the 3, we're going to get 2t plus 6. So both sides of the equation are the same. So once again, this is another all. The next one, we have 3 times n plus 1 equals 3n plus 1. If we distribute this 3, we're going to get 3n plus 3 equals 3n plus 1. Well, the 3n's cancel, but then we're left with 3 and 1. 3 does not equal 1, so this is a none. Remember, none is when our variable cancels out, and what's left is not a true statement. Whereas with the all, the two t's would have canceled, or the n's cancel. What we get is the same. All right, this next one, we have 1/4 times 20d plus 4 equals 5d. If we distribute the 1/4, same thing as dividing by 4, we're going to have 5d plus 1. Is that going to be a true statement? Nope, not equal on both sides. All right, our next one over here, we've got 5 minus 9 plus 3x equals negative 10 plus 6 plus 3x. So we've got the 3x's the same, which we need to either be all or none. So what we need to do is simplify. So 5 minus 9 is going to give us a negative 4, and negative 10 plus 6 is going to give us a negative 4. So this is all, because they're the same on both sides. The next one, 1/2 plus x equals 1/3 plus x. 1/2 and 1/3 are not the same, so it is none. All right, the next one, we have y times negative 6 times negative 3 equals 2 times y times 9. So in this one, we got to simplify what the coefficient would be on our variables. So negative 6 times negative 3 is positive 18. So we have 18y equals 9 times 2 is 18. So also an 18y. So that means it's an all. And then the last one, v plus 2 equals v minus 2. 2 and negative 2 are two totally different things. So this is none. So the key thing you should be noticing about all these, though, is the coefficient and the variable are the same on both sides in every single one of these. So that makes it so that the variable cancels out. And that's when we have those all or none solutions, because we end up with that true statement of 0 equals 0, or 1 equals 1, 2 equals 2, whatever the case may be, because there's no variable. Or in the cases of none, we end up with 5 equals 2, 10 equals 1, all these crazy things that are completely false. So we know that they can't be true for any values. All right, for number 2, write the other side of this equation so that this equation is true for all values of u. So best way to take and do this is to look at what is this side of the equation simplified. So if we distribute the 6, we'd get 6u minus 12 plus 2. Negative 12 plus 2 is going to give us 6u minus 10. So that's what it needs to be equivalent to. So one possible solution is just saying 6u minus 10. Those are completely equal, which means that it would be true for all values. Now, for this one, same expression, but now we want it so it's true for no values. So that means we need to have the same 6u, we need to have that, but then the other part of it needs to be different. So we can leave it as just 6u, that would be false because we'd have negative 10 equals 0, completely false statement. And we could throw in any number so long as it's not negative 10 after that. So we could say 6u plus 10. We could say 6u minus 100. Either of those, any of those would work. So there's a lot of possibilities for what will make it true for no values. Very few that will make it, there's essentially one way to take and have it true for all values. It has to be something equivalent to this. Now, could we do something like this and have, the distributive property going on, adding, subtracting, and have to simplify it down? Of course. Yes, definitely. But you just have to make sure it would simplify down to this right here. So that way they'd be equivalent. All right. So looking obviously at a lot of equations. So here, what's the equation? Equations is your keyword for this lesson, equations. So I have an S on the end. Complete each equation so that it's true for all values of x. So we have 3x plus 6 equals 3 times x plus what? Well, 3 times what is going to give us 6? 3 times 2. Our next one here, we have x minus 2 equals negative something minus x. So we know this negative is going to change whatever's in here, the sign on it. So we need it to be a negative 2. So that means here we should have it be a positive 2. That's supposed to be a 2. Kind of, sort of. Sorry. All right. The next one, we have 15x minus 10 all over 5. So we're dividing all of that by 5. So 15 divided by 5 is 3. So we have a 3x. All right, now this next one, we want to complete each equation so that it's true for no values of x. So that means we want it to be different. So essentially, for this one, so long as we don't plug in 2, it's true. So we could say 3. But basically, we could say any number other than 2. For this next one, same idea. We can plug in anything. We can say 10 or any number other than 2. Like I said before, there's a lot more options for the no values of x than for all values of x. And then the last one, we can make it 2x. So any expression. Oops, actually I'm wrong. We need it to still be 3x because we want it to be no solutions. This would give us exactly 1. Whoops. I got in the habit of just changing it a little bit. So we still need it to be 3x, but we'd make it 3x plus 5. That would change it. Any expression of the form 3x plus a, other than having a being 0, obviously. So for number 3, how do you know whether an equation will be true for all values of x or true for no values of x? So kind of like we've been saying, equations which are always true for any value of x have equivalent expressions on each side. So equivalent, whoops, spelled that wrong. Equivalent expressions. All values. Whereas equations which have no solution for any value of x simplify to a statement of unequal numbers being equal, which is always false. So for no values, it's a statement of unequal numbers. So finding that false statement of unequal numbers being equal, no values of x. So basically, like I was saying before, your variable cancels out and you're just left with numbers that don't actually equal each other, but according to the equation, they're supposed to. So that's when we have those no values of x or no solutions. Okay? So if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.